Hey guys, my name is Ellis. I'll be talking to you today about memory analysis. So, what is memory analysis? Memory analysis is part of the digital forensics world, and memory analysis is needed because sometimes data is locked or hidden or deleted. Um, there are times where people don't want us as investigators to find out what they've been doing, so they choose to go through different means to hide or delete evidence of their actions. So, digital forensics is used to collect and preserve digital evidence, and it's also used to support or refute hypotheses before courts. So, this is the kind of things that will put people in jail with the evidence that we collect, and hopefully, it keeps innocent people out of jail by proving that they did not do what has been said. There are five primary branches of digital forensics, and each branch is categorized by where data is stored or how data is transmitted. The first would be computer forensics, then there's mobile device forensics, network forensics, database forensics, and forensic data analysis. And forensic data analysis is an important part of that because a lot of times we get information directly from the data. So it's important to be able to analyze that directly. So, what exactly is memory analysis? Memory analysis is also known as memory forensics, and it's a technique that is used for analyzing the RAM of a computer for different kinds of forensic artifacts. So, memory analysis is used to identify and investigate malicious behaviors that don't necessarily leave easily detectable traces on hard drives. Um, with memory analysis, we can provide unique insight into the runtime state of the system activity, including things such as open network connections or recently executed commands or processes. And memory analysis can assist with unpacking, rootkit detection, and reverse engineering. So, what kinds of tools are available to us when we need to analyze memory? Well, there are many different tools used for memory analysis. There are open source tools as well as proprietary tools. There's open source tools like SleuthKit and Autopsy. There's also the individual SleuthKit and the individual Autopsy. Um, there's also Kane. There's Volatility, which I'll be talking about in a little bit. And there's Explico for open source tools. Proprietary tools include tools like ProDiscover, Ncase, and Forensic Toolkit, or FTK. And these proprietary tools are usually tools that they use in industry by like law enforcement. These tools usually tend to cost a lot of money, and they're more in depth, I guess, than open source tools, in different ways. So I'll be talking today about the volatility framework. So volatility is an advanced open collection of tools that is used for memory forensics. And the great thing about volatility is that it's implemented in Python. Um, Volatility is able to extract digital artifacts from the volatile memory samples, and volatile data can include things such as browsing history, chat messages, or other app information that isn't often stored on the device and is unlikely to be recovered. So in order to extract the evidence, there needs to be something to extract it from, and that's where memory dumps come in. So memory dumps are files that contain a copy of a computer's volatile memory at a specific time, and usually this time is when a system crashes. So Volatility provides us some functionalities that even Microsoft's own kernel debuggers don't support. And it's got some extraction techniques that are completely independent of the system being investigated, while still offering visibility into the runtime state of said system. So this is a nice little visual that I found from one of the websites when I was doing my research, and it shows you all the little things that you can find when you analyze a memory dump. So it can show you diagnostic information, or if you've got a memory leak, what are the reasons that there may be behind that, or if you had a system crash, or if you suspect suspicious activity. And then there's obviously stuff such as like bugs and errors, and malware, of course, that you can find when you're analyzing your memory dump. So Volatility can analyze raw memory dumps. It can also analyze hibernation files and various other formats. And Volatility analyzes memory from 32-bit and 64-bit systems. So it'll do 32-bit and 64-bit memory analysis for Windows, Mac, and Linux devices. And the cool thing is it'll also do some 32-bit Android systems. So it can analyze some of those as well. So this image is from the same source that I found the earlier one. And this one lists the pros and cons of Volatility. So some of the pros that they list here are that it supports various file formats, that it runs on Windows, Linux, and Mac, and that it shows the running processes. It also shows open network sockets, and it has a repository with profiles for different operating systems. And then it analyzes RAM dumps from large systems using fast and efficient algorithms. Now, some of the downsides that they list here are that there is no graphical interface for Volatility. And this means that you need to do everything through the command line. So if you're not really comfortable using the command line, maybe Volatility is not the tool for you to use. And then another con that they had on this one is that there is no 100% guarantee that the information that you need will be extracted. But I guess that goes for any tool, really. And then this is a list of pros and cons that I felt that should have been added to the other list that didn't make it on there, so I felt I could add it onto my presentation here. So some of the pros are that it is open source GPL v2, and that means that you can read, you can learn from, and you can extend it. Because it's in Python, it's really not that hard to, write some scripts and add some extra little things to Volatility that some extra features that you might need. And then it also provides the capabilities to solve complex digital crimes involving things like malware, intelligent threat actors, and your typical white and blue collar offenses. Now, some of the cons that I found were that it doesn't provide memory sample acquisition capabilities, so it won't extract the image that you need. So you'll have to use something like GUI Major to be able to get the image. So now I have a little demo for you guys, and we're going to be exploring volatility a little bit, and I'll show you some cool little commands that you can run, and it'll show you some information that that'll be useful in an investigation. Alright, so in order to save some time, I've got my virtual machine already up and running. I downloaded Volatility from their GitHub, and I've downloaded a memory sample of a malware called Cridex, which is a banking malware, and I've got that installed. So the first thing I did was to preserve the integrity of the file. I changed the mod to 444 so that it's read-only, and then I created a SHA-1 sum to make a hash so that we can compare it to at the end. So I've got all my read-only and my hash created. Now, the first command we want to run is the image info command, and that command is going to give us information about the memory dump. So we'll go ahead and run that. So once this command has finished running, we can see that it's got a couple of different suggested profiles. We see the WinXPSP2 times 86, and we see the WinXPSP3 times 86. So these are the two different profiles that we will be trying to find information from. Alright, so now that we have the information on the operating system that this dump came from, we'll run the pslist command, and this command is going to show all the control processes and their descendants. So I'm going to go ahead and run that. So here we can see all the different processes that are running and their descendants, so we can trace all of these back to the original. So for example, we can see the explorer.exe, second from the bottom. The parent process is going to be 1484. If we trace that back, alright, so I made a little oopsie there. So I meant to look at the reader.slexe, and the PID for that is 1640, and the parent ID is 1484. So if we trace 1484 back, we see that it goes to explorer.exe and it goes to 1464. But if we look through, we don't find 1464. So that's kind of a clue that we've got something off there. Now let's go to another command. So after looking through all the processes and getting a feel for, what we might sort of be looking for, like what might be sketchy and whatnot, the next command I'm going to run is going to be conscan, and this command is basically going to just check out what open TCP connections are used by the process and so on. So let's get that going. So once that's finished running, we can see that that parent ID 1484 from earlier that just kind of ended up disappearing off into nowhere has a connection that is open. So I'm going to show you one more command just for the sake of time. So the last command that I'm going to be running here is going to be the cmd line command. And this is going to be a command that is going to display command line arguments that will hopefully give us some cool information or useful information. So if we scroll through, we can try to see all the parent IDs that we looked through earlier. And if we scroll down, maybe we see something that we saw earlier. And here we can see that 1484 was a process that was opened by Windows Explorer. So these are just some of the commands that are really beneficial to run to find out information on a memory dump. So those commands will hopefully give you a better view of the information that you can find within a memory dump. That was basically the duration of my demo. And let's see, that is the duration of my PowerPoint. Thank you guys for taking the time to watch this, and hopefully you guys learned something cool. If you guys have any questions or anything, feel free to post it in the discussion board, and I'll be able to answer your questions and hopefully interact with you guys a little bit through there. These next couple slides are just the references that I use, and that's the end of my presentation. Hopefully you guys learned a lot.